Hello everyone, my name is Aarav and today I will be teaching you all about the infrared sensor and what it does. And so quickly, a message before I begin, I will be switching through the slideshow in the EV3 LEGO Mindstorm coding software so I can give you um, some brief overview on the actual step-by-step process of how to do it. So, today, as we're talking about the infrared sensor, which is this right here, the infrared sensor has its own block. And so, what you need to do is you need to go to this yellow sensor tab. And within this tab, there are multiple different sensor blocks that you can select from. But today, we are talking about the infrared sensor, which is right here. And so, even if you're not sure where the infrared sensor is, if you hover over the tabs and even the blocks, it will tell you what tab and what block each represents. So, say that you hover over the yellow tab, it will tell you that it is the sensor tab right here. And then hovering over each individual blocks, it will say, okay, this is the brick button block, this is the color sensor block, and this is the infrared sensor block. So if we go in here, let me just reset this, then you can see, okay, this is action, this is flow control. Oh, and here it is, it's sensor. So let's see, if I'm trying to find the infrared sensor, this is brick buttons, color sensor, and then here's infrared sensor. So this would be your sensor. So the infrared sensor has many different properties. The first property is the channel. So the channel of the remote is the thing that's sending commands. So this right here is the remote. And so if you can see that this red rectangle looking thing, this is the channel. And so what it does is there's this little tab at the top right there. And as you move it up and down, there are four modes that you can go on, or four different levels. And that can represent channel 1, channel 2, channel 3, and channel 4. So whenever you want to pair to your robot to use the remote control, you need to make sure that they're on the same channel. So say, for instance, that it's on channel 1, right? Like how it shows in this block right here. It would say, okay, I need to make sure I'm on channel 1. So it would say, am I on channel 1? Yeah, I'm on channel 1 because it's at the very top. And then, so the way that you can change the channels is you just have to click right here, and I'll tell you channel 1, channel 2, channel 3, and channel 4. Channel 1 is usually the default channel, but say that you're on channel 3, and your remote control is on channel 1, it will not work. You need to make sure both are on channel 3. So to make sure you're on channel 3, you have to pull this down, so 1, 2, 3, and you see how that little rod looking thing moved down? That would be channel 3. Okay, so that's channel. Then heading, another property, is a numeric or number value from -25 to 25. So 0 of the heading values means that the beacon or the remote control is directly in front of the infrared sensor. The negative values indicate that the beacon is left to the sensor or the beacon is right to the sensor. I am pretty sure that this is your right and this is your left. So if I show you real quick, say that this is the sensor, then this is 0, and then this is your left, I'm pretty sure, um, then this will be a negative value. And then if this is right, your right, then this would be positive values. So then that's heading, and then the proximity property is also a numeric or number value from 0 to 100, and it represents the distance from a beacon to another object, or the relative distance to the beacon, sorry. So 0 means very close, and 100 means far away. The proximity will always be 100 if the beacon is not detected at all. So say that this is 100, right? So then as I move closer and closer and closer, the numbers will get smaller. So say this would be 50, then this would be 10. And like if they're touching, then that would be 0. So then the last and final property is the detected logic or true or false property. So the true so for this property to be true is if the infrared sensor beacon or the remote is detected on a specific channel, which means that if the robot is on, or if the infrared sensor is on channel 3, then that means that the remote control also has to be on channel 3. If the remote control is on channel 2, then the infrared sensor has to be on channel 2. So they have to be exactly the same for the detected logic to be true. But say that if this was 2, if the remote was 2, but then the infrared sensor was 3, then it would be false because they are not on the same channel. So moving on to the infrared sensor measure and compare. So the measure and compare are the two different types of like modes that you have. So measure and compare, and within it they have their own types like proximity, beacon, and remote that you can click on to perform specific tasks comparing to proximity, beacon, heading, and all that. They are pretty self-explanatory, such as measure means the measurements as numeric number values to other blocks. And then compare means the measured values against a threshold to provide logic values. So in this video, we are going to talk about the measure. And then in the next video, we will talk about the compare. So let's dive into the measure. So, oh, sorry. I don't know why it's doing that. Here we go. I'm sorry about that. The measure options. So let's go here. I'll show you how you can get to the measure options without it being difficult. So if you go to measure, then you'll have your own individual options. So proximity, beacon, and remote. Right now we're on beacon. And so you can click on any one of these three and they will provide their own specific purpose for what you want to do. So the proximity, as we talked about, which measures the distance to the nearest object. So let's just say that my hand would be a wall, right? And then this would be the infrared sensor. Then as the infrared sensor gets closer to the wall, the value would decrease, and as it gets further away, the value would increase. So say this would be 100, then this gets to 50, and then you move back a little so it goes to 75, and such stuff like that. Then the beacon, which means it estimates the robot's proximity to the heading in relation to the remote infrared sensor beacon. So that means just the distance, right? So say that this is like 10, this is 20, this is like 50, and then like something over here would be 100, right? So that's what that is. So proximity means distance, so the distance away from the beacon. And then the remote, which means it receives commands from the infrared sensor beacon, such as like move forward, or such as um, many other things too. So let's go on to some infrared sensor measuring examples. So these will help like clear up some of the basics for like what you need to know. So the infrared sensor measures the proximity and passes the value to the move steering block through data wires. So the sign might be covering it, but you see this yellow wire that feeds through the infrared sensor block and the move steering block. The data wires just connect the data from one block and move it on to the next one. So this program makes the robot steer based on the distance measured by the infrared sensor. So, as we can see, depending on the proximity in the infrared sensor, it tells it to move a certain amount of distance. So, here's a perfect example. So, say that this would be an object, correct? And so, this is the sensor. So, now say this is 100. So it's basically saying, okay, move 100, right? And then as it moves, the data values or the input from the infrared sensor to the block keeps on changing depending on the value or the proximity away it is from the object. So as it goes from, let's say, 100 to 90 to 80 to 70 to 60, like then all the way to 0, the data values will keep on reassessing and re-changing until it comes to a full stop. And so this is just one example. There are also other examples that I will show you too. And so let's just move on to the next one. So the next one is the measure proximity example. So this program makes the robot gradually slow down as it approaches a wall or another object. So in the one above, we were looking at the distance it moved, but for this one, we're talking about the speed it moves. So it uses the infrared sensor block in the measure proximity mode to get the proximity on a data wire, this yellow wire. You can see it much more clearly now. And this value is used for the power input of the move steering block. So input, let's just clarify this firsthand. You might already know this, but the input is the values being put into the block. And then the output would be this yellow wire, and it is the things being released or things being like let out or being told to other blocks to do that specific purpose. So I personally do coding, I do Python. And so in code, if you input something, like say that you input like words, then you say, I want you to print these words. And when it shows the words on the screen would be the output. But then the code that I actually write to make those words would be the input. Okay, so this is the infrared sensor measure beacon example. So in this example, the infrared sensor reads the value of the beacon heading and passes the same value to the steering block using the data wire. The output of the heading value is from -25 to 25, hence the robot moves front, back, or straight depending on the heading output. Whoa. Sorry about that. Okay, so let me just explain this one. So we have our infrared sensor, and then we have our remote control. So remember earlier how we talked about how this is 0 and then there'd be -25 or 25? And so what this does is it's saying, okay, if it's 0, then don't move. But then say when you move it one way or another, either it's -25 or +25 or somewhere in between, because it can be in between too, then it would either move backwards, so backwards -25, or forwards 25, depending on the distance, or sorry, depending on the speed. So it changes the varying speed. Okay, well, that was part 1, and then I will be back with part 2 soon. Thank you. Hello, everyone. This is part 2 to the infrared sensor video. In the previous video, we talked about the measure options that were available in the infrared sensor block, and now we're going to talk about the compare options in the infrared sensor block. So let's get into it. So the compare option has different sub options. As you can see here, proximity, beacon heading, and beacon proximity modes. Compare the sensor data to the threshold value using the selected compare type. And then the true or false result is an output in compare result, and the sensor data is the output in the chosen sensor data type. So this is probably one of the trickier ones to understand, but it's fairly easy when you understand it. So what we are trying to explain here is that actually, let me go into the code just to show you. So here we have our compare type. So we have equal to, not equal to, greater than or equal to, less than or equal to. And so what we're doing here is we're saying that, okay, if the infrared sensor's distance is greater than or equal to 50, then we are going to have a true statement. But say that it is less than 50, then we're going to have a false statement. So it's the same thing as in math, right? Like x is greater than or equal to 50. So that means that x can be either 50 or higher, which would make a true math statement. But if it was below 50, like 49 or lower, then that would be a false statement. Okay, and the last option in the compare section is the compare remote. So the compare remote mode uses the infrared sensor in remote mode. You can select one or more button ID values in the set of remote button IDs. The compare result output will be true if any of the selected buttons is currently pressed on the infrared sensor beacon. The button ID output will be the button ID of the current press button or button combination. So, right here on our infrared sensor remote, or just our remote, we have, as you can see, these individual buttons. We have 2 buttons here, and then 2 buttons here, and then 1 big button up here. So what that does is it's saying, okay, in the infrared sensor, we're going to have it be defaulted to button 1. So if we press button 1 on the infrared sensor remote, then it will be a true statement. But say that they say you need to press button 1 for it to be a true statement, but say you press like button 2, then it will be a false statement because they're not the same button. And let's go back into the software and I will show you how you can change these. So as you can see, when you click on it, it gives you these multiple options. So there's 0 if you don't click anything, 1, 2, 3, 4, 5, going all the way to 11. So if we're on 1 right now, that means that I need to press button 1 in order for it to be a true statement. But say I press, say, button 2, then that won't work because that will not be a true statement. Okay, so let's move on. Oh. So as we explained the different button IDs in the remote, and then let's go into some examples. These examples will really clear things up for you, and it'll help you gain a better understanding and knowledge of what's going on. So, here's a perfect example, okay? So what we're saying here is keep on going forward, right? So that's what this block is. It will keep on going forward. Then over here it's saying when the block is going to be less than 50, then you need to stop. So say that your robot is within less than 50 as the distance. So here we go. So we have our infrared sensor right here, and say that this is a wall, right? My hand's a wall. So as the sensor keeps on going, right, because that's the first block, it's going to keep on going, then it comes within 50, right? So when it comes within 50, it says, okay, whenever it's within the range of 50, then you wait. And then after it waits, the last block means that it just turns off. So here's the text. So the program will make the robot drive forward until the infrared sensor detects that it's close to a wall or other object. After the driving starts, the program uses the wait block in the infrared sensor compare proximity mode to wait for the proximity to be less than, in this case, 50, not 35, before stopping the robot. Okay. So this is another one. So infrared sensor compare beacon heading uses a switch block. So what a switch block does is it basically says if it is a true statement, then you have to do the one on the top. But if it's a false statement, then you have to do the one on the bottom. So you can see that there's a check mark. The check mark represents true, and then the X represents false. So as we see in this code is that if it is a true statement, then it says flash green. So your brick will flash green right here. And then if it's false, then it will flash red. So the program uses the infrared sensor from switch block and compares the beacon heading value. If the beacon heading is less than 0, status light turns green. But if it is not 0, if it's not less than 0, then the status turns red. And then here's the final one. So, we have 2 more. So the infrared sensor compare beacon proximity using the wait block. So the proximity will make a robot start driving when the infrared sensor beacon is on, and gets close enough to the infrared sensor. It uses the wait block infrared sensor compare beacon proximity mode to wait for the proximity to be less than 20 and then drives forward for 0.5 seconds. So what we're trying to say here is that if the infrared sensor beacon can get is close enough to 50, then what it does is it uses this weight block to say, okay, once when it's within the range, then we stop and then we drive forward for 0.5 seconds. Okay. Infrared sensor compare remote using weight block. The program makes the robot wait until a button on the infrared sensor beacon is pressed using channel 1. So as we talked before in the first video, you can use and switch this this red rectangle right here with this little tab. And what you can do is you can change the channel by pushing it up. So that would be channel 1. And then pushing it down would be channel 2. And then pushing it down would be channel 3. And then channel 4 would be at the bottom. But right now this code is on channel 1, so we have to keep it all the way at the top so that the infrared sensor remote beacon and the actual infrared sensor can read each other. So, the program makes a robot wait until any button on the infrared sensor beacon is pressed, as we said, using channel 1. Then it drives forward for 1 rotation. It uses the weight block in the infrared sensor change remote mode. If you start with no button pressed, this will wait until any button on the infrared beacon is pressed. So, say that when this is on, and then say you keep on waiting and waiting, and then you say, okay, I'm going to press this button. So when I press this button, then what will happen is that our robot will start turning for 1 rotation. And then say that you want to press another button, then it will do the same thing. So that is about it. Thank you for watching, and have a good day.